This podcast was brought to you by Meros Cryptocurrency. Meros is a cryptocurrency payment system that does what cryptocurrency originally intended to do. Be a practical and secure form of direct payment, Meros utilizes the best of current technology in a powerful new way. It introduces a groundbreaking consensus mechanism called merit caching. This enables Meros to be both feeless and instant while maintaining the same level of integrity of traditional networks like Bitcoin. To find out how you can participate in the future of crypto payments, go to meroscrypto.io now.
Hello and welcome to State of the Project Meros. This is a monthly podcast which charts the development and the progression of the Meros project, and each month we go into depth on things that are happening in the GitHub, and also we dissect some of the aspects of the tri-weekly update, which is also posted to Medium. So make sure that you check those two things out. I'm going to make sure I put the links in the description, but I'm not going to talk too long. I really want to get into this one because we've got an absolutely packed show, and I'm delighted to be joined by the lead developer of Meros, Kayaba. Kayaba, how are you?
Great, as always. It's a pleasure to be back.
Yeah, it really does seem like time has flown. It feels like only yesterday we were doing the April update. So I'm really excited to have you on. The first thing I really wanted to speak about was the critical bug, which was found and immediately fixed. And the non-critical bug, which was also fixed. I spotted both of these in the GitHub, both fixed a few days ago. So could you explain to us a little bit about the critical bug that was fixed and then the non-critical bug?
All right, so there's this bug. The critical one was where if you had a client who was trying to sync the chain, and whoever you were syncing from sent an invalid message. This could be for a few reasons. It could be that the client, the person you're syncing from, was invalid. It could be that they didn't realize you were syncing yet and they just sent you a normal piece of network traffic. Could just be a glitch along the way for whatever reason. It would bubble up, meaning that it would go from the message handler to the network stack to the rest of the program, and it would just keep on rising until it crashed the entire program, which obviously isn't okay. So that's why I added a critical bug. It just meant that anytime you're syncing, the malicious person could crash your node. So this was actually observed in February on the 2nd, and the plan was to fix it in our cleanup. So we spent the last 3 weeks cleaning up the Meros node. The main focus was error handling. So with this being a great example, we did handle errors, but there were some errors going through the cracks, and we kind of had two different styles going on. In some places, we would use booleans, true or false values, as status codes. And in other places, we would use full-on exceptions, where if something went wrong, we would throw an exception. So we just kind of had two different styles going on, and we also weren't getting full coverage. So we spent a few weeks really just saying, this node needs to be cleaned up. It's going to create a friendlier and more explicit system that will be easier to use. It's going to allow us to expand, and it's also going to fix some bugs that are currently facing us. So we did the 3-week cleanup, and we also didn't just touch exceptions. We also did a couple of optimizations and some needed protocol changes, like not just optimizations, but stuff that really would have made the protocol problematic. And we finished that actually like an hour before we published our tri-weekly update. And this bug was fixed as part of it.
Okay, and there was also a non-critical bug, which was something to do with syncing. Could you tell us about that?
Sure. So as I said, when you were syncing, it was possible for the node to send you an invalid message, and one of the ways it could do that was if it just sent you a regular network event, like a new block. It could send you a new block not realizing that you're syncing, and then realize you're syncing and say, oh wait, don't send you any network events because you're trying to sync, and that has a very specific target, and I shouldn't try to send you all this other information while you're just trying to catch up. So now, in order to remove that, because even though we handle the errors, the client that's syncing still thinks that's an invalid message. So later, that's going to go into what we call a karma system, where each node kind of has ranking, and if it dips below a certain score, we say, okay, we're done with you. You're being too problematic. Let's disconnect you. But for now, that can just cause a disconnection because we don't have that karma system yet. So we added during the cleanup a new message called syncing acknowledged. So if I send you syncing to tell you that I'm syncing, and you send me a block at the same time because you just don't realize yet that I'm syncing, then you would send syncing acknowledged, and I would just ignore all your messages until then, guaranteeing that when we continue, we're on the same track.
Interesting, very interesting. And you say that this led you towards doing this quite substantial code-based cleanup. It was something like 7,800 additions and 9,000 plus deletions. So could you tell us a bit more about the things that you improved, and also, I guess more importantly, how will the impact on Meros?
So we've done cleanups a few times throughout the history of Meros. Of course, just none have been extensive as this. A while ago, we cleaned up the networking stack because that was being problematic, and we really just redid it in a safer and cleaner way. So really, just as we grow our code base and keep going, things are expanded upon, and ideas that were good at the start are no longer the best solution. So cleanup is just a way of maintaining code quality. So this recent one, our primary focus was the exception system, which really was throughout the entire code base. And I have to admit that our original exception system wasn't optimal even at the time. I wanted to use Boolean status codes just for simplicity at the start, but then midway through I realized that exceptions would be better and faster. So I tried switching over to those, but that left half and half because I had yet to remove all the Boolean status codes. So this really just resolved the two systems and made it more explicit. Now every single exception is tracked throughout every single step. It's actually a quite verbose solution. Thankfully, it doesn't affect the speed of it. This thing in programming called zero-cost exceptions, where exceptions, if you try to handle something which might throw an exception, it runs as the same performance whether or not it was in what's called a try-catch block, as long as it doesn't throw an exception. If it does throw an exception, then yeah, there's a speed cost. But if it doesn't, it's the same exact speed, thankfully. So that was our main focus, but we also moved some files around, and we worked with the verifications DAG. Previously, the verifier had a Merkle. Merkle meaning a Merkle tree, where if you have A, B, C, and D hashes or pieces of data, you hash A and B together to create hash AB, hash C and D to create CD, then hash those together to create a single hash representing the entire tree. So previously, the verifier had a Merkle all of their verifications, which would not scale, and then to that we effectively had the entire verification stack in RAM, even though we just added a database. It really just was not a scalable or pleasant solution. So now we only have the verifications that have yet to be mentioned in a block. And as soon as they're mentioned in a block, we just clear their Merkle and move on.
Awesome. I did actually read about that. For those of you who are not familiar with the Tri-Weekly Update, it is an awesome resource. And I actually, I had read about that precise piece of information in the Tri-Weekly Update. So it's great to that you're being able to share that with us here on the podcast as well. And what I also wanted to speak about was after cleaning up Meros significantly, you then went and actually cleaned up Mineros. Now, I don't think we've actually discussed Mineros yet on the podcast in any of the episodes, and we may have touched on it, but could you tell us what Mineros is, and how will these new changes or these new improvements, how will they affect its users?
So Mineros is our own miner. It's a portmanteau of miner and Meros. The name's just to be a little witty and fun. So it's our own miner that currently works with the Argon algorithm. It asks our RPC for a block. It just sets a single miner for now, which is whoever you say to pay out merit to. It mines the block, and then when it sees that it beats the difficulty, it submits it back. It's a very simple program. And what we did is we updated it to the latest Meros files, because just for compatibility, we had to update it to the latest standard. And thankfully, since they're both written in NIM, and we've done a very good job of compartmentalizing the code base, which means that each piece is on its own and works without needing a ton of other stuff. We can literally just copy over files from the Meros code base and drop them into a folder on Mineros, and it works.
Awesome.
So with the cleanup, we were mainly focusing on updating it to the latest Meros. We did simplify some parts of the code that just were more complicated than they needed to be, yet we didn't apply the same rigorous exception handling just because it's really a simple program. Right now it's less than a couple hundred lines, I think, and there's not a lot of exceptions going on. It also doesn't have to perform as well as Meros itself when it comes to stability, though of course we are trying to make it as stable as possible, and I haven't noticed any full crashes in a while.
Awesome. Okay, moving on. I noticed an update to the Blackbox part of the Meros project. Now, this has been somewhat shrouded in mystery for some months now, but the plan or the actual update was just an update to what is quite a plain. It's just a text file that says what the to-do list is, and the plan is to add an API. Now, what does having an API mean for Meros, and what sort of features will it allow Meros to develop in the future?
So the black box is a bit of an experiment of ours. So a black box, by definition, is something that you put data in, and you get the same output out no matter what. It is an isolated piece of code that takes things in, takes things out, and you don't actually touch any of the internals. For all you know, that black box is running a simulation of the entire universe, and it used more processing power than ever used before to get your answer. All you know is that you put data in, you get data out. So the experiment was, could we take a couple of developers, new to Meros in general, and sort of ease them into the project by not having them work with the main Meros code base for now, but setting them up on a side project where they could apply their own styles and conventions to a point. So there is a goal to have it match up with Meros, of course. We're not creating two separate projects, but it was a way to sort of integrate developers. And we do have a developer who stayed on, and they are currently working on the black box. So our black box, it's actually meant to run Meros script. Meros script is not a smart contract language, and I want to say that now. It is not Turing complete, which means you can't actually run loops. You can't say, do this 100 times. So you create a script, or a set of scripts, that say these funds can be unlocked if these requirements are met. It's really comparable to like Bitcoin's scripting system, which says when funds can be released. So with Meros script, it's just conditions for releasing funds inside the lockbox. That's the name of the entry on the lattice. And then the black box actually evaluates Meros script and says, yes, these funds should be unlocked, or no. So when it comes to an API, that just means how we pass data to the black box and how we get data out.
Awesome. Thank you for describing that. I want to move on to the community questions. The first few actually come from a person whose name is actually name within squared brackets. I'm assuming he's a developer because they're quite tough questions. The first one, I'm going to have to edit it a little bit because what he actually asked was for a thorough explanation on why CPU mining is better than GPU or ARM CPU mining, please. I guess this person doesn't know that we only have half an hour. So if you could give a brief explanation on why CPU mining is better than GPU or ARM CPU mining, could you give us that explanation? If you indeed think that, could you explain?
This podcast has been brought to you by Rhubarb Media. Rhubarb Media are the branding specialists behind successful crypto projects such as PivX, Vendible, and Libertaria. The Rhubarb style is both loved and respected the world over. So if you want your project to appeal to techies and everyday users alike, give Rhubarb Media a try. You cannot possibly be disappointed. Link is in the description.
So just to set a bit of background here, Meros is going to be a CPU-only cryptocurrency. The miner blockchain to get merit. We're looking at the random X algorithm right now because that's currently the top CPU-only algorithm. And use that merit to vote on transactions, which earns you Meros. So the point of being CPU-only is to increase decentralization. Everyone who interacts with Meros will have some form of CPU, but not everyone will have a high-end GPU or an ASIC or an FPGA. And I've heard claims about making FPGA and ASIC designs open and increasing competition and letting the market sort it out. But you're never going to have enough. There's always going to be more people with a CPU than an ASIC. And as we've seen with companies, they don't actually release ASICs. They mine with them in secret for months and then release them. So that's why we like CPU mining. The whole purpose is decentralization. And of course, there are concerns about botnets and server farms, but we're hoping that the high memory requirement will disqualify botnets. And then server farms, with GPU, we also have GPU farms. And with ASICs, we have ASIC farms. There's always going to be farms. So the question is, why is it better than GPU mining, first of all? And that's why it's just increasing decentralization. More people are going to have a CPU than a GPU. And we're also hoping that the farm situation will be better because the people with CPU farms will mostly be, say, VPS or VDS providers, and hopefully they're not going to try to use all of their resources on experimental cryptocurrency. Really, we're going to have to see there. But of course, with GPUs, we also have farms there. So I'm confident that with CPUs, we can achieve higher decentralization. Then for ARM CPU mining, to be clear, when the original CPU mentioned was presumably x86. It's a CPU standard used in most computers. ARM is another CPU standard that's lower power at the cost of speed that's used in, say, phones. And when it comes to ARM CPU mining, I don't have a problem with that at all. I don't want to do just ARM CPU mining or just x86 mining. I would hope that RandomX or whatever algorithm we end up using, probably RandomX, would run well on both. That said, there's still more people with x86 devices out there, especially with the RAM requirement of RandomX, which disqualifies a lot of ARM devices. But no, I don't have anything against ARM CPU mining.
Awesome. When you was making the decision, was decentralization the top priority for choosing how mining was done? Was anything else considered, or was it just decentralization?
Besides decentralization, there's also security concerns. You have to have a large hash rate to be secure. But if your hash rate is, let's pick just random number 10. Let's say your hash rate is 10. That said, one person controls 6 of your hash rate. If they have 6 out of 10, they can attack your network at 51% attack. With Meros, we have a lot of safeguards against that, thanks to the split between mining and voting and some other things we're working on. So you would actually have to mine for 6 months straight. Not 50% at 6 months. You would have to get half of the existing merit. And since merit lasts for a year, that means you would have to get 6 months of merit, or 51% of 1 year. So we actually have a lot of safeguards there, but it's still theoretically possible. So really the focus is decentralization, not to be decentralized, but to be secure and to be open and fair.
Awesome. And I've seen, to be quite frank, I've seen that the transparency that Meros has been showing since the start of the project, with everything going straight up onto GitHub and these podcasts as well. So transparency along with security and along with decentralization, it's a pretty good trifecta. The next question that this developer called Name also asked was, what's the Meros block time? And I guess you could say a little bit about what the block time actually does.
Sure. So the Meros block time is 10 minutes. And the way we get instant transactions, which we've covered before, is through our merit caching algorithm, which I briefly covered with our previous question. You mine the blockchain to earn merit, and then merit is used to vote on transactions, and those votes are valid instantly. So as soon as a transaction gets 51% of the votes, it's a valid transaction, and you can move on. So because of that, even though the block time is 10 minutes, it really only serves archival purposes. That said, when it also comes to lockboxes, which is Meros locked according to Meros script, those are decided by the block time. There isn't an optimal secure way to do that outside of the block time. So lockbox interactions are also locked to the block time. But besides that, the block time only affects archival, so nothing that the average user really is going to be concerned with. And because lockboxes are locked to the block time, we are considering a 5-minute block time instead. But right now the plan is to use 10 minutes.
Awesome. Because generally within crypto, people would assume that if you have a 10-minute block time, it will take 10 minutes for a confirmation on transactions. And I guess that's one of the strengths about the merit caching system, is that just simply isn't the case for Meros. The next question that he has was how much memory in terms of hard disk drive is used on average per transaction, including verification.
So we discussed this a bit last time, and I do have some better numbers this time. So right now it takes, I believe, 200 bytes to store a transaction on the disk itself. And then right now, every vote adds, I believe, 96 bytes. However, we can safely get that down to 200 bytes for the transaction itself. And for the verification, we can actually get that down to roughly 3 bytes per vote. And then 48 bytes per verifier per block. So with voting, we're looking into what's called a nickname system. So when you see a transaction, you say, this is transaction 0, this is transaction 1, this is 2. And this numbering system is only on your local computer, not affect the network whatsoever. But now, when you get a vote, you're not saying transaction with 48 byte hash got a vote, you're saying transaction 2 got a vote. And 2 can be represented in a single byte. Of course, we need more than a single byte because that would only limit us to 256 transactions. But using a nickname system and also reorganizing how we save verifications, we can get this down to 48 bytes per verifier per block plus roughly 3 bytes per actual vote, with the transaction on the disk taking roughly 200 bytes, probably a bit of savings there as well.
How is Meros as fast as IOTA claims to be without using obscure centralization?
I personally don't think IOTA has obscure centralization. I think it's a pretty well-known fact that they have a coordinator who, there's now an open source version of it, but I don't think they're running the open source version on mainnet yet. And it's a centralized security system. So I personally don't think it is obscure, but that's not really the question here, of course. So I actually got into this debate with some fans of IOTA a while ago, and IOTA itself actually doesn't make claims about its speed. If you look at the actual network times, they're getting 3 minutes per transaction to be safely confirmed. And while the fanboys, they're claiming that it's instant or almost instant. The actual website itself, even when I went through the Wayback Machine, I couldn't find the word instant on it. So IOTA's not claiming to be instant, and they practically have 3-minute block times, and it's very, very easy to beat that. One of the things IOTA's trying to do with their DAG is they're really trying to promote a potentially sharded vision where you only need the part of the DAG that matters to you. While that matters locally, to drive consensus, there still needs to be a group of people who have the full copy of the database, because else that 3-minute time is going to take longer and longer to be safe, especially as a lot of their consensus is driven by transaction generation, and a lot of people are just, when they create a new transaction, they just verify the original transaction. Anyway, sorry, my point is, IOTA is a very weirdly designed system that's getting 3 minutes per transaction. IOTA fanboys claim it's instant, but the foundation itself isn't claiming that. We're beating it because we focus on keeping all the transaction data, and we have a set point at which a transaction is confirmed. It isn't when we get 90 new transactions or whatever. It's when we get 51% of votes, and the people who vote have a full copy of the database and watch that and get paid for their voting.
Yeah, it did strike me as a quite a strange question, but you've done a fantastic job of explaining exactly why IOTA is not instant or even close to it. Moving back to Meros now, and I have to again thank you for your time, because it's been a real a real eye opener this month. So could I ask, what do you have planned for the upcoming month within Meros? What kind of things will you be working on, and what sorts of things will we be expecting to see?
So really, I'm working on the protocol specification, which will eventually become our white paper. A lot of the protocol has just been written out as code, but that makes it hard to quickly review, because you're not just browsing a document that specifies why and what, but you have to go through the code and kind of see how it connects. So it's not really a good way to write out our protocol at all. And because we don't have that written out protocol, we can't get the protocol audited yet. And it also means it's easy for things to fall through the cracks, where we write one thing here, but that relies on another thing and then doesn't get implemented. And because of that, we actually do have a few bugs on our GitHub. So we're writing out a finite definition of our protocol so others can review it, and we can easily reference it, and we can see what is the current Meros node doing that does not conform to the protocol. So really, it's just our way of saying, here's what we have, here's what we need to do, where's the feedback?
Okay, and do you plan on having this white paper completed within the next month?
So the protocol specification is being uploaded to GitHub Live as it's written. And I do hope that we can get those documents on GitHub. It's just some text files. I do hope we can get those done within the next 3 weeks. That said, for the full white paper, we might look at 6 weeks, because once we finish writing these down on GitHub, we may partially write the white paper, but then also get back to development as well.
Awesome.
And a
awesome.
split time frame there.
Yeah, awesome. All right, well, Kayaba, thank you once again. Thank you very much for your time. It's been absolutely riveting. It's been particularly technical this month, which I think a lot of developers will really appreciate, but then also a lot of people who are maybe technically minded but not quite developers will also appreciate. So thank you so much for taking the time to explain some of these complex challenges so eloquently. It really has been a joy. Is there anything else you want to say about Meros before we sign off?
No, it's just, as always, been great to be here, and I'm happy to answer all your questions.
Awesome. Well, Kayaba, thank you very, very much. And to everybody who's listening and watching, thank you very, very much. Please like and subscribe so that you get the latest updates from this massively promising project. It would really benefit you to do so. So yeah, thanks for listening, and I'm looking forward to speaking with you again, Kayaba, and getting back to State of the Project Meros for June. So thank you very much, and bye-bye.
Adios.
This show is brought to you by PivX, private instant verified transactions. With its groundbreaking zero coin staking and masternodes, PivX is the top privacy currency. Feel free to trade some on Binance or Bittrex. And for more information, go to www.pivex.org.